Hi, I'm Jan Ozer. When I looked at AV1 software, looking at the open source alternatives, Libaom and SVT AV1, one of the questions that came into my mind was whether both code bases would be continued, because it seemed like a lot of emphasis for the Alliance of Open Media was on SVT AV1. So today I have with us Andrey Norkin, who's a senior research scientist for Netflix and also co-chair of the Alliance for Open Media's Video Codec Working Group. And he's here to answer that question and more. Andrey, why don't you give us a little bit about what you do at Netflix and then what you do for the Alliance for Open Media?
All right. So, hi, Jen. I'm a senior research scientist, which means I work on the video in video algorithms. So, and that's mostly compression. And I've been at Netflix for more than 7 years now. So I've been working in different, let's say, areas, including also our encoding pipeline. So the team that I'm working on is the encoding technologies, which basically owns the software for the Netflix encoding pipeline. Recently, I've been contributing quite significantly to the Alliance for Open Media, and I am also basically coordinating Netflix efforts for contributing to the Alliance, and that included AV1 previously, and also some next steps, let's say, in whatever AUM is doing, which we can speak about.
Okay. So what's the answer to the question? I mean, it seemed like the Alliance for Open Media formed a working group, and it seems like all the effort was going to SVT AV1. What's going to happen to those two code bases? Because SVT isn't as convenient to use as Libaom within FFmpeg. At least at this point, it's not.
All right. So basically both code bases are going to be supported going forward, but they have different purposes. So the Libaom is the reference software for AV1. It has been the reference software, and the emphasis is on completeness, first of all. So it should cover the whole AV1 standard, whereas SVT AV1 is more of a production code base, or the code base that basically is optimized to work with with a lot of parallelization, for example, on very multi-core machines. And it also, so you can say that it's more or less a production code base. So two different working groups in AV Media use these two different code bases. So the Libaom is the reference software that is used by the codec video codec working group, which basically develops the specification, and the SVT AV1 is used by the software implementation working group that basically does this effort of optimizing the software. And you can say that seeding the ecosystem with some base that can further be used to produce maybe even better encoders.
Okay.
So maybe I can also tell that there is also a project that is spin-off from Libaom, which is called AVM, and that's basically the reference software for research efforts beyond AV1. So that's basically, you can think about what's coming next, the next specification, and that's based on Libaom. And this is also going to develop in parallel with both Libaom and SVT AV1.
Okay. So as it stands, or as it stood when I looked at this back, I think it was around June or July of 2022, SVT AV1 and FFmpeg was single pass only. So when do you expect to see two pass SVT AV1 and FFmpeg, or has it already been provided?
I guess I would need to look exactly if when it's going to be provided, but more or less the question is what exactly from the two-pass encoding do you think is missing in SVT AV1? So you can use one pass or two pass, right? It just depends, but you want to get some functionality from your encoder, right? So if a single pass provides it to you, then it probably should be fine as well.
Okay. So let's look at the playback side. So when AV1 launched, I guess it was in 2018, the mantra was silicon in 12 months and consumer products for playback in 24 months or 2 years. And I think there were some TVs that came out in May 2020 with AV1 support, but it feels like the mobile platform in particular has been dragging on that. So what's the status of that now, and what do you see happening in the near term to kind of correct that?
So I think I tend to agree with you that the hardware support may be somewhat lagging, but the hardware support is actually increasing. So there are several manufacturers that have produced TV sets with AV1 hardware decoding support. So like that includes some models from Samsung, like 4K and 8K models, and LG Electronics. Also, as far as I know, there is Toshiba and Insignia that have models that support AV1, and also some of the Sony's Android TVs, they support AV1 hardware decoding. So the support is growing, and we expect actually that the more and more TVs going forward will be supporting AV1. On the mobile side, so far, Samsung have been supporting AV1 in their Galaxy S21 and S22 families, and also MediaTek supported AV1 in their Dimensity chipset. So, which means AV1 will be supported in some of the models based on this chipset. Also, you can see some support on the computer or PC side growing. So basically, Tiger Lake and Rocket Lake chipsets are supported by Intel, and some of the video cards such as NVIDIA GeForce and AMD Radeon. Some of the newer cards, they support AV1 decoding as well, and also Intel Arc GPU. I believe that supports both encoding and decoding. So the support is going. It may be somewhat slower than what you would hope for, but the support is growing, and I think it's going to get better with time.
Okay, how has software support kind of filled the gap?
Oh, that was really important, and a good thing was that AU Media and also some other companies like Netflix and Facebook, they actually invested in developing software decoders. So also Google developed the LibGAV1, and the other one that was David, that was basically coming from AU Media and the companies like Netflix and Facebook. So that was really important because while there is not a sufficient support in the hardware, you can still play AV1 in software, but you need a really efficient software encoders. And I think that David and LibGAV1, they are two very good decoders. They are optimized both for x86 and for ARM Neon instructions. So they are doing their job before the more of the hardware support would come.
So just out of curiosity, I know that Apple hasn't come out and supported AV1 yet, but can you, I mean, if you have an app that runs on an iOS device, can you have AV1 decode in that? And if so, what kind of frame rate and resolution would the software decoders give you?
Oh, that probably would depend on what exactly the device is. So I guess I would have a difficulty answering that question. in principle, software decoding, it depends a lot on the device capability, and that's the reason you actually want hardware decoding, because software decoding is best effort, right? So sometimes you would probably be fine with a lot of content, but if the content is particularly difficult on the decoding side, then you may have probably like dropped frames or something like that. Yeah.
Okay. I mean, I think I've seen some sources saying that Android can do 720p 60. I mean, I guess the more recent iPhones are really powerful devices. You know, you would think they could do. I mean, I've seen software playback of AV1 on a really old computer, and 200 or 300 frames per second. So, I mean, are we talking 1080p 30, or are we talking, that would be successful, or you just can't say? I guess I don't want to push you to say anything that you don't feel comfortable.
Yeah, I guess I can't say really. Since I haven't personally tested it on Apple devices, then I would rather not give an answer.
Okay, but I mean, it is possible to include any codec that you want in an app.
That should be possible, because if you provide the implementation and you just use the instructions available in the system, then it should be working.
Okay. One of the features that seems to be holding AV1 back, and I know you know this because you're one of the biggest publishers of HDR content, is HDR support in technologies like Dolby Vision and HDR10 and 10 Plus. When do you see AV1 becoming supported by those technologies?
So I think I need to correct you here, because I think that there is no problem using, for example, HDR10 with AV1. I think it's supported outside from the box, more or less, because what you need to signal the color space and some other parameters, and also a couple of metadata or ACI messages, and all of that is supported in AV1 specification directly. So for HDR10 Plus, there is also some work that has been happening in the Alliance for Open Media to clarify how the HDR10 Plus would be supported with AV1. So basically, where exactly you should insert the HDR10 Plus metadata in the AV1 bitstream. And I believe that this work should be finalized by now. So basically, you can say that HDR10 and HDR10 Plus should be supported. And I guess I cannot give you an answer about the Dolby Vision yet.
What does that mean, it's supported? I mean, I bought a Samsung TV 2022. Is HDR10 and AV1 just going to be magically supported on that, or are they going to have to issue updates, and is it only going to be new TVs going forward? What's that going to look like on the playback side?
So I think what you really need to have in order to support AV1 on let's say on a newer TV, you first, of course, you need the AV1 decoding support, and also it needs to be an HDR TV, and then the decoding is going to be fine, and the only thing you really need to signal is the let's say your color space, so that colors will be represented correctly on your TV. So I think it's going to work. So you are going to see HDR. For HDR10 Plus, it may be a little bit. You may want to check really if the dynamic metadata, because the difference between the HDR10 Plus and HDR10 is this dynamic part where you can actually change luminance. You would need to check whether this part works, but you would see HDR in any case, I think, because like even if you remove, even if the metadata because of any problem, for example, if it's removed, then you would see HDR10. So I think but hopefully my hope is that HDR10 Plus works on the TVs which say, let's say, HDR10 Plus and AV1. So in any case, you are going to see HDR, I think, and it shouldn't be a problem, because if you use correct signaling for the color space and for the transfer function, then then it's basically the TV is going to interpret this signal as HDR signal, and you're going. So basically, the answer is I think it should work.
Sounds like a lot of testing before Netflix ships that.
We actually we do a lot of testing in any case.
I'm
so,
sure.
For any new codec or any new format. So we certify devices. So each new device we add is certified that. So we are sure that everything actually is displayed correctly.
Okay, so who is using AV1 at this point, and what are they using it for? Where are they sending the streams?
Basically, Netflix, of course, Netflix is using AV1 so far. So we've been streaming AV1 content to Android phones, to various smart TVs, and also some streaming devices like game consoles. We also stream it to browsers, to a significant number of them, and seeing great results, and which we are planning to share sometime in the future. So in addition to Netflix, at least from what I heard, the companies that support AV1 are YouTube, for example. That's a big one. So they are streaming AV1 in a reasonably high volume. So also from what I heard, that their VCU or video coding unit, actually supports. Yeah, they support AV1 basically as an ASIC, and they support encoding up to 8K. So and my understanding is that that's already deployed. So in their data centers. In addition to that, other companies are also increasing the support in the video industry. The examples are Facebook, for example, Twitch, Vimeo, and also iQIYI, which is a company from China. At least those are the companies that I know of. Also, on the real-time communication side, I believe Cisco announced that they were rolling out the AV1 support in WebEx, and also Google announced that they would be rolling it out at Duo at some lower resolutions. So in principle, more and more services are using AV1. Also, some of the cloud services have been supporting AV1, including the AWS from Amazon and also A1 from Alibaba. I believe also Atem is supporting AV1 in their Titan service, and the Bitmoving encoding service, they support AV1 as well. At least that's what I know of from the let's say press. So that's I don't know if that's a complete list, but AV1 is used by a number of service providers.
Okay. What is film grain synthesis, and why is it essential for AV1 and even codecs that are not AV1?
That's a good question. So, and the answer is that film grain synthesis basically allows you to reduce bitrate while still preserving the film grain. So, I guess film grain is very common in movie and TV content, and directors like it because it gives a movie some look. And typically, film grain is coming from some sort of analog process in the film. At least that's how it originated. Nowadays, sometimes film grain can even be added as a post-production, because as you can imagine, digital cameras typically don't produce film grain. They produce sensor noise, which is somewhat different. So a lot of content actually does have film grain. And the problem is that film grain is very random and it resembles noise. And as you may know, noise, like white noise, is uncompressible. So it's really difficult. And okay, film grain is not quite a random noise because the grains have certain size, but it's nevertheless it's very difficult to reproduce it faithfully at reasonable bit rates. So when you try to fit the bitrate in your streaming budget, or for example, even at the levels constraints, sometimes the film grain would be lost on some of the frames. And that's where the film grain synthesis kicks in. So what you can do instead, you can remove the grain, denoise the original sequence, encode it with a good quality, decode it at the decoder side, and then the film grain is actually at the encoder. You estimate the grain parameters and send these parameters along with the video, and then on the decoder side you basically synthesize the grain and add it back where it belongs to. And since the grain look is basically estimated based on those parameters, then it would look similar to what you had on the encoding side, even though every single grain may not be exactly in the same position where you would expect it to be, but it still would look better than if you try to actually compress it. So one other thing that you actually may be interested in is that AU Media is currently working on a specification for a standalone film grain. So basically, so you know that film grain is supported in AV1, so that's a mandatory tool to support. However, currently the AU Media is working on a specification that would have a standalone film grain with a transport using the ITUT T35 user registered metadata, which means you are getting the unique identifier for this type of film grain from ITU, and then any codec that supports ITUT T35 metadata, which is basically any codec that you would find currently on the market. It should be able to basically carry the film grain over as a, let's say, as a payload in their SCI messages. And if the display device supports the AV1 film grain synthesis, then this metadata can be used to generate, basically to synthesize it and use AV1 film grain with other codecs as well.
Interesting.
It's still in progress, but it's going to be finalized fairly soon, I hope.
So you would need an AV1 decoder or an AV1 compatible decoder in order to, I guess, layer that on top of the decode of whatever other codec it was.
I think it may be it may help, but in principle you can implement just this part, right? If you want, and so just the film grain synthesis, that's also an option. If you don't have an AV1 decoder on chip. But if you have an AV1 decoder on chip, then the manufacturer, I guess, they can make the necessary, let's say, adjustments in order to be able to use it with other codecs. I would think so.
Okay. So if looking forward even further, if AV1 was interviewing to become the codec for the metaverse, what would its major qualifications be?
That's a difficult question, and that's a little bit a fuzzy question, I would say, because if you speak with different companies, like what they assume what the metaverse is, then they would probably tell you different things. And well, so if we look at the simplest scenario, right? Like if you want to stream something from the server where let's say your metaverse is rendered to your headset, for example, if you want to use AV1 or any other codec at this link, then you would need basically several things to be supported. Like, first of all, is high resolution. You need levels with fairly high resolutions, because typically since the screen is very close to your eyes, then let's say any resolution decrease would result in in a pretty grainy picture. So the high resolution is a must. Then low latency, of course, so that the picture wouldn't lag when you, let's say, turn your head, and also tiles and possibly some support for stereoscopic video, you may think. So actually, some of this work is even currently being addressed in the Alliance for Open Media. For example, recently we have adopted levels for higher resolutions in AV1, in addition to what was defined in the in AV1 in the last release. So these levels are 16K by 8K and also 32K by 16K. Which is a pretty high resolutions. These levels are going to be, let's say, published when we have the next version of AV1 specification released. So then I guess tiles have been supported from the very beginning. Also, the encoding of spatial layers is supported in AV1 decoder. And that means you can actually have prediction between pictures in a different. If you want to encode the stereoscopic video, I guess you would still need to add some signaling, but hopefully you can do it at some higher, let's say, higher level. Yeah, so that's basically what you may need, and I think AV1 should be fine. Of course, you would also need to have an encoder with a very low latency. If you are going to get further into Metaverse, and you may think about objects compression, so that you may want to compress some volumetric data, and that's again this is probably going to be then AV1 plus something, and this and to develop this something, the AU Media has actually created a new working group, which is called Volumetric Visual Media Working Group, and that's exactly has been created to address the augmented reality, virtual reality applications, and also some 3D acquisition data, such as LiDARs and so on. So basically, the goal of this group is to develop specifications for encoding and streaming of volumetric data. And some of this would likely use the video codec as some underlying, let's say, compression tool. So currently, this group is gathering requirements and use cases, and is planning to issue a call for proposals this year. So that's kind of, if you look at the AR applications going further.
Okay, you've kind of touched on this a couple of times, but when do we expect to see something called AV2?
That's a good question, and I don't think that we can give an answer to that yet. So basically, and the reason is that we are currently working on the research beyond AV1, and we have some improvements over AV1. However, we don't want to give the date yet until we reach a certain point when we think that basically now it's actually ready to be to become a standard, or that the specification just needs to be written. So as soon as we think that we have a sufficient improvement over AV1, then I guess we would have this date. Otherwise, research is unpredictable. So you may think that you can provide some compression at some time period, but with research sometimes it doesn't always hold. So that's why we prefer not to give an exact date yet.
I really appreciate the time you're able to spend with us, and thanks for clearing up the SVT versus Libaom and all the other topics that you've addressed. So thanks for taking the time, and I enjoyed it.